All right, guys. So, in our chapter here on ratios and proportions, we're going to talk about something called a rate of change, or specifically, the lesson is called constant rate of change. So, we're going to talk about those two things, and so you're going to see how we're going to use unit rates and proportions, or the idea of proportions, to talk about something that's slightly different than what we've been talking about, but it's just closely related. They're almost the same. All right. So here we go. The very first word is rate of change. Everyone. Rate of change. All right. So here's what the rate of change is. Okay. Your book says a rate that describes how one quantity changes in relationship to another. A rate of change is usually expressed in a unit rate. So it's how the amount of one thing, if it increases or decreases, how does it change in relation to another? Okay, another thing that it's talking about. So guys, those two things, of course, are talking about two different units, right? That's what we've been talking about lately when it comes to things like proportions or unit rates. It's about two different units. Okay, so how does one thing change and what happens to the other? Okay, here's what I want you to put in your little box. Go ahead and put unit rate. All right, now a rate of change is not exactly a unit rate, but considering that it's usually expressed in a unit rate, we'll go ahead and write unit rate down as a little reminder. Okay, now our next word, we talk about a rate of change. Now there's a special rate of change, and that is a constant rate of change. Everyone? Constant rate of change. All right, so before we move on, those of you that are feeling pretty good at your reading abilities, what is the word, your vocab abilities? What's your word? What does constant mean? What is constant?
It's like always happening no matter what.
Always happening. Okay. Frequently. So kind of a synonym. Repeatedly. That was your word. Okay. It's just consistently is another one. So it's just always occurring, always happening, right? So if we're talking about a rate of change, sometimes a rate of change over a big amount of time, it itself could change. So there's a certain rate. If we're talking about a graph, it changes. A constant rate of change is continuous. It's constant. It always happens in the exact same way. So here's what the book says. This is the rate of change in a linear relationship. A linear relationship. Now, just a little side note, because we're going to be dealing with tables today, and we're going to be dealing with graphs today, both in the same lesson. Okay? And so, when it comes to their definition, they're, of course, talking about a graph. How do I know? Well, this word right here, it has this suffix, okay? And all that is basically kind of changing it into an adjective form, describing relationship. What's the root word on that, though?
Line.
Yeah, it's line. Here's what that means. It's a relationship that when graphed forms a line, or in this case, a straight line. Okay? So we've been talking about graphing lately, right? And a straight line means it's constant. It keeps going exactly the same way on and on, right? What we were describing constant being like. So that's what it means when you graph it. It's going to become a straight line. Okay? So here's what I want you to write down. It'll take you about a minute or so. Go ahead and write this little chart down in your box. It doesn't have to be this big and that wide. Just a little mini version of this chart right here, this table. All right, so go ahead and write that down in your box. Okay, so the top row, all right, in this table is all about the number of pizzas. So 3 of them, 5 of them, 7 of them. The bottom row here is all in relation to students, the number of students, that is. There's 15 of them, 25 of them, 35 of them. Okay. Now, here's what we're going to do. We're going to do a little more to this chart. I'm actually going to kind of teach the lesson Okay, I'm not going to go into detail step by step right now, but I want to give you a rough idea of kind of what it looks like, at least on a table like this. Okay, so listen, here's what this means. Let's say we're having a party. Okay, if 15 students show up, I'm going to have to order, okay, 3 pizzas. Now, here's what happens. If I take a look here, if I have 15 and then all of a sudden I look up and there's 25 in the room, there is a change in numbers. It's an increase of what, guys?
10.
Of 10. I look up again, there's an increase from 25 to 35. What is an increase of?
10.
Constant means it's going to keep happening consistently. 10 plus 10 plus 10. Okay, on a chart like this. Now listen, see pizzas? If 15 are in there, I'm going to have 3 pizzas. However, look at if 25 end up, how many pizzas am I going to have? 5. So that is an increase of what?
2.
What that means is that I'm going to have, if there's an increase of 10 students, I need to increase the amount of pizzas I purchase by 2. Same thing here. Look at this. It's an increase of 2. Okay? So what we're going to do is that's kind of how it shows. That is the rate of change. If one quantity, that's what the definition says, if one quantity of students increases by 10, the other quantity of the other item of pizzas has to increase by 2. That's what that's talking about. Okay? That is called a rate of change. And because in this case it's constant, that would be considered a constant rate of change. Okay? So we'll talk, it actually goes a little bit further than that. We're going to talk about that during our lesson. All right? So here's what I'd like you guys to do is to please go ahead and grab your books and let's take a look at some examples. We're going to start with number 1 on page 69. So go ahead and grab 69, page 69, and take a look at problem number 1. I need eyes up here when you're ready to go, and we'll move on. All right. Thank you, Angel. You're one of the first ones that I see that have your book out. Eyes are up here, ready to go. Awesome job. Okay, here we go. All right, so what we're going to do is we're going to take a look at page 69, problem number 1. Now, I made copies of the book pages. Unfortunately, the copies are pretty bad. The nice part is like usual, your copy's good. So you just kind of have to ignore that a little bit of the back of the page bled through. Okay, so it's a little harder to see, but just kind of ignore the shading part. And of course, refer to your book page if you can't see something. I'm going to zoom in a little more. All right, here we go. All right, so it says find the constant rate of change. They're telling us it's constant. We don't have to find out if it's constant or anything else. It's the constant rate of change for each table. So we're starting with the very first kind of problem. It's talking about tables and finding the constant rate of change, kind of like the one we did in our vocab. All right, so here's what we're going to do. Okay, the steps are going to probably take longer to write out than doing the actual problem. So here we go. Step 1, all right, is we're going to go ahead and we're going to find out the rate of change for the first factor. Now, on a table, and this isn't overly important in the table, but I want to talk about this because we can refer to it later and see the link between tables and graphs. But these are like ordered pair. You can think of them as ordered pairs since we've talked about ordered pair recently. This factor right here in the chart is going to be our x-coordinate if we were to graph it. Okay. The second column here, the distance in this particular one, this is our y-coordinate. And we're kind of I'm just getting you ready for not only this lesson, but a future lesson as well to make it a little easier. Okay. Now here's what we're going to do. Step 1 is go to your x-coordinates and find out what is the rate of change in your x-coordinates. So, look at this is pretty easy, right? 1 to 2, it's an increase of 1. 2 to 3 is an increase of 1. 3 to 4 is an increase of 1. Okay? Thank you, those of you that are writing your notes down. That's exactly what we should be doing. So what this is saying is there's an increase in seconds, right? Time, I'm assuming S is seconds, so an increase of 1 second each time. Now comes step 2, and that is we're going to do the same thing for the y column, the y coordinate. So this is, of course, distance in meters. So we're going to go ahead and show there's an increase in this case from 6 to 12, a 6. And then from 12 to 18, that's also an increase of 6. And if you ever wonder, if it's a larger number and you don't know what the increase is, go over and subtract. Find the difference in the two. But 18 to 24 is also an increase of 6. Okay, here's what I want to do next, all right? Step 3. When we express this, we're going to express it, and remember it's usually expressed as a unit rate, and we're going to get there. So the way we're going to do this, though, is we're going to actually express the change, this is the change in y over the change in x. Okay, I'll kind of put that in parentheses. That's more of a reminder than something you have to write down every time. We're doing the change in y over the change in x. So the change in y right here is what we just wrote. It's a change, it's an increase of 6, positive 6. Then we look here and go, okay, well, what's the increase of x? Well, I take a look at what we did here. It's an increase of 1. As a matter of fact, if you want, you could pay, it's an increase of 6 m's, meaning meters, 6 meters. For every increase of 1, and this is all in s, right, seconds. So in this case, it means for every 6 meters that is probably traveled, 1 second goes by. Okay, so every time you go 6 meters, an increase of 6 meters in your travels, there's going to be an extra second that passes. Okay, that's what that means. Now, I'm going to go ahead and write step 4 here. I'm going to put a star by it, though, because it doesn't always have to happen. And here's what it is. Reduce. In this case, you can put down the word unit rate. Now, here's the nice thing about this one, right? This one's already in a unit rate, so we don't have to reduce on this one, but some you will have to. Now comes step 5. Oops, I put 4 when I said 5. Step 5. And that is, I'm going to go ahead and write it out in words, my final answer. We've done this before. We're going to write out our unit rate. So here we go. 6m stands for 6 meters. 6 meters. And instead of putting 1 second, I'm going to put the word per, right? What we've done before. 6 meters per second. And there's our final answer. There's an increase of 6 meters per second. You look okay. Yeah, you're okay. $11:45, right? Why don't you wait 2 more minutes? Okay, it doesn't take you guys 5 minutes to pack up. Okay. You'll be all right. Okay, 30 seconds, guys. I want you guys to try out problem number 2. Problem number 2. All right, go ahead and get started. Go. All right, how many of you need more time for number 2? Okay. Okay, guys, how many of you still need more time on that one? Okay, now listen, when you share, here's what I want you to share. I'll always start off, because like I said, everyone's always dying to talk about their answer. So go ahead and start off with your answer, compare your answer with your neighbor. But here's what else I want you to do. I want you to compare to make sure that your neighbor is showing their work properly. All the way down the charts, just like this. The constant rate of change down the side of the table. Okay? All right, 30 seconds. Turn and share. Go.
$90 per item. So first I do, so I know the rate of items are +2.
Yes.
And then for 18,
Yeah, you need to log
it's
on.
+18. And then I do 18 over 2, and I do simplify it. So if I do by 2, I got 9 over 1. $10 over 1, I got $9 per item. And the same thing. You just, yeah, I saw. I was like, I didn't know if they had like this is simplified. The unit rate, so it's like he left it here. And then it says step 4 if we have to.
All right, here we go. I'm going to zoom out just a little bit because I want you to see both our notes here and the work I'm showing. So, guys, I kind of walked around a little bit. And I saw some people not do some of the steps. I look at their notes and their steps aren't in their notes. Even though it's right here, it's not in the notes. Make sure you're taking good notes. Okay? Because you're skipping steps, it's gonna decrease your chances of being successful on this. All right? So here we go. Step 1, right, is find, I have right here, I'm going to find the increase in my x. All right, now there we go. All right, my x coordinate. So here we go. Increase of 2. This is an increase of 2. This is an increase of 2. Then step 2, find the increase in the y. So this is an increase of y of 18. Now, if you didn't know that, you can go over to the side. 36 minus 18, it's 18. Okay? This, if you want to check to see if it's an increase of 18 again, here's what you do. Just a little extra mental math skill. I can add by 20 and then subtract 2 at the end, and that will give me 18. So 36 plus 20 is 56. Subtract 2, well, that's 54. So yeah, that's an increase of 18. Same thing again, right? 54 plus 20 is 74. Subtract 2 is 72. That's an increase of 18. So it is a constant rate of change. I'm going to go ahead, do step 3, which is I'm putting my y over my x. So my change of y right here is 18. In this case, it's dollars. And over the change in x. So my change of x is an increase of 2. In this case, 2 items. I'll put I for items. Now comes my next step, step 4, and that's why we wrote that in there. We're going to go ahead and we're going to reduce and trying to get to our unit rate. So our unit rate is 1, or for 1 item. Well, I just divide both top and bottom by 2, right? And we get $9 over 1 item. And now it's ready to write down as our final answer. All right? So here we go. I go ahead and write down $9 per, and then that 1, right, is talking about the item. $9, an increase of $9 per item. Okay? All right, questions? Yeah, but some people don't know what 54 plus 18 in their head is. They'd have to go over to the side. So I'm trying to do some mental math to save you guys some time in writing. Oh, yes. So you have to be very, very careful with that, though. And we'll talk about that on Tuesday, because it's coincidence that that's the case, but it's not consistent. Okay. Good idea of kind of looking for patterns. I like that. Okay. Just be careful with that. Okay, guys, other questions? Okay, so we have one more type of problem that we're going to take a look at. So let's go ahead and let's take a look at problem number 3. Yeah, problem number 3. Okay, so problem number 3 is a little different. It's a little word problem here, so let's go ahead and close read it. It's basically the same kind of problem, but now instead of dealing with a table, we're going to be dealing with a graph. All right, so move it up a little bit. All right, here we go. Let's close read this. Here we go. It says the graph shows the cost of purchasing t-shirts. Find the rate of change for the graph, then explain what points 0, 0, and 1, 9 represent. All right, so they give us a couple ordered pairs there. All right, so here we go. The very first thing is that they're asking us to do is find the constant rate of change. Now, remember what I told you guys. I was kind of getting you ready for a little bit later this lesson, but also I'm getting you ready for in the future as well. But that is, here's what step 1 is. Go ahead and find out your rate of change as y over x, meaning what is the change in y? Now listen carefully. The change in y is you're going to choose 2 dots. There, just might as well take the 2 dots that were used to graph this straight line. Okay. Now the change in y, do not go diagonal up the line. We're going to be tempted to do that. All we want to do is find out how far between this dot and this dot did it increase on the y-axis. That's the change in y. Okay? So it went from 0 to what appears to be 9. So what I want to do is on this particular one, they actually tell you, if you look over here, there's your y. Yes, it's 9. So what is the change from 0 to 9, guys? How much did it change? 9. Okay? It's an increase in 9. Okay, we don't have to do anything with the chart like we did up here. We just look here. It went from the first point to second. On the y-axis, it went up 9. Now, from this point to this point, on the x-axis, it goes from 0 to 1. It's a change in 1. And we can actually, if we wanted to break it up, we consider that step 2 if we want. You find the change in y, then you find the change in x. Okay? Now step 3 is reduced to a unit rate. And this is one of those, again, that it's already set for us. Now comes step 4. Step 4, guys, is just basically step 5. Okay? So step 4, it is 9. Now, be careful, that's the y-axis, so we're going to need to look here for our units. If you wanted to put it on here, you could, $9. And this, the x-axis, is number of shirts, so 1 shirt. So when I write it here, it is $9 per shirt. There's our first answer. They're asking us to find the constant rate of change. Now, it does say, then explain what these 2 points represent. Now listen, the explanation is easy. All right, the explanation is easy. I'm going to. It's one of those what I call cookie cutter answers, meaning it's going to be the same no matter what. All right, I should say the formatting is going to be the same. So here's what I'm going to talk about. Here we go. We'll call this step 5, even though it's just writing it down. Take your first ordered pair. put down 0, 0 represents 0, 0 represents. Now we're going to go ahead and put our X first. So what's the X-axis again? Number of shirts. So 0, 0 represents 0 shirts. And then what's the Y? This Y here, it's the cost, right? So represent 0 shirts, costs $0. So the 0.00 means we don't buy any shirts, it's going to cost us $0. That's what that point represents on this graph. Guys, this explanation, and this will be on quizzes and tests, so make sure you're listening carefully. The explanation is pretty easy once you get the hang of it. Okay, it's actually testing us on if we know. It's testing us on whether or not we know how to read a graph. That's what it's really doing. Okay, so here we go. We're going to go ahead and continue step 5. We all have our pencils in our hands. We're writing this down. This is important stuff. Thank you, those of you that were still writing your notes. Step 5 is 1/9 represents, and remember we're going to start with the X, so it is 1, and remember the X is in shirt, so 1 shirt costs, and then the Y, which is 9, right? And it is $9. And that's how you do problem like 3 with the explanations. You can put the $sign if you like. Okay. Guys, other questions? Say that again.
On number 3, I put something else that's similar to what you put on here.
Number 3 is similar to what? What I put on where?
On question number 3, on the sentence, explain it.
Yeah, these two right here, step 5.
Yeah, I wrote something else, but like it's similar to it.
I mean, there could be a little bit of a difference, guys. Listen, though, please do not go too far off of this, because I have students that are trying to be individuals and write their own sentence and be creative, and then what they happen to do is they end up leaving something out, and it costs them a point. So please don't get too creative, okay? But if you want to share it and see if it's right or not.
Yeah, I put 0.00 represents 0 t-shirts purchased and $0 spent. 0.19 represents $9 spent for 1 t-shirt.
I mean, that would work. That would work. Okay, because it does have the same meaning. You have what the 9 is and then how it's related to the 1, right? And you have the correct units. Those are all what's important. Okay, that works. Okay. All right, guys, other questions? Okay, so here's what I want you guys to try out. Go ahead and flip your book over to page 71. I want you to try out problem number 12. Problem number 12, all right? Problem 12, go. How many of you need more time? Okay. Okay. Anyone need more time? Okay, just a few more seconds. Okay, guys, here's what we're going to do. Take a look up here. Let's take a look at problem number 12. It says use the graph to find the constant rate of change. So compare it with what you have. So here we go. The change in y, remember that's our first thing. The change in y goes from 0. It appears to be 75, but you have to be careful. That dotted line is even with the dot, and it is under 75. Look here. It's 72. So the change in y is 72. The change in x, from this dot to this dot, right? It's going over, and that is exactly 6, and it shows right there. It is 6. I can go ahead, and it is 72 pages, right? We can put, I'll just put P for pages for right now. 6 is time in minutes. I'll put M for minutes. But what I could do is I can reduce both by 6, and it becomes 1 minute on the bottom. I could do long division, but I would get 12 pages printed per minute. And as a matter of fact, what just came out of my mouth is our unit rate. 12 pages printed per minute. Okay, there's our first answer. Now, here we go. 0, 0 represents, and the x is first. Remember the x is minutes, so represents 0 minutes it takes to print 0 pages. Right? 0, the second one, 0 is the y. And then I'm just going to pretty much copy it for the next one, but just change my numbers, right? So it is 672 represents 6 minutes it takes to print 72 pages. All right? Questions on that? Hold on. We have 2 quick announcements to make about this.
Could you write it as 1 minute and 20 pages?
See me after class. We'll take a look at it. Okay. All right. Really quickly, here's thank you those of you that are following directions, because it's just going to make it go a little longer here. A lot of us are wasting time for everyone to get out to lunch. Thank you, those of you that were doing that. Sorry about that. Here we go. Really quickly, I want to talk about 2 things. Take a look at page 68, number 1. Okay, they have 2 people that are saving money, and you're going to have a problem like this on your homework. There's 2 people saving money, and they're just asking who saves more each week. So what you have to do is you have to do what we've been doing. You have to find the rate of change, or their unit rate, and compare them.
Baker, please come to the Rayburn office. Piper Baker, please come to the Rayburn office.
The second thing that it asks is to explain. Here's all you have to do with your explanation. You have to write your unit rate. So you could say, Mi Ling saves more because she saves $50 per week, while Daniel only saves $20 per week. Okay, so you just put your unit rates in there. Take a look at 6A. Be very careful. I want you right now to underline. It says write the constant rate of change in miles per second. That is referring up to the cartoon. Please make sure you're careful with how you set up your unit rate. Okay? All right.